Last week we reviewed some handout section on introduction to Python, and I hope we've been practicing extensively. Yeah, do we have any challenge so far? Have we encountered any challenge in the process of our practice? Anybody? If we have any challenge in the process of practice, we can share your screen if you are joining with your laptop, and so that we can resolve it. And if you don't have, you can just drop a thumbs up. Oh, you are fine with last class. And how was the quiz? I hope we enjoyed the quiz so well. All right, that's fine. So this morning we'll continue with the Python class. And if you are joining with your laptop, yeah, you are free to share your screen and also code along. And if you want to watch while we perform some of the coding, that's fine. And if you have issues along the process, you can quickly uh, draw my attention back so that we resolve it easily. So, just a quick review of what we did in the last class. So we look at the background of Python, and we look at some keywords in Python, and also we look at the rules of creating variables. Like we said, variables are the horses of programming. If you don't have good knowledge of developing good variables, uh, you may run into issues in programming. So we also look at different types of data types. Like we said, there are different classes. Some are classified numeric, some are classified as strings, some are classified as sequences, and a lot more. So there are so many types of data types. So, but the primitive one, we looked at them in the last class. Yeah. So, I will look at how to define this, and we conclude the class by performing some if statements. Yeah, that's good. And we also introduce us to some IDE for Python, like the Visual Studio Code, the Jupyter Notebook, and yeah, the Colab. So we said if you don't have a laptop, you can use your phone as uh, as a programming device, logging into the Colab. Yeah. So those were the things we observed in the last class. So we'll quickly look at some other condition, some conditional statements, and look at the loops and the control statements. So let's look at how this operation works. Then we'll look at functions. Then we'll go to how to handle files in Python. I can cover this and how to use files. I think we are fine. So we can be able to work with the goals of the program, which is Python for data science. Yeah. So let's quickly jump down to the notebook. So yeah, we look at some operations in Python last class here. Okay, we look at some operators as well. So we stop at control statements. Yeah. So yeah, Okay, let's just take it off from this place. So we said you can also develop multiple if statements. Say if you have so many if statements, so you can like, okay, you want to extend this if, so you perform an elif statement. Say you have, let's say you have x, let's say x is equals to, x is assigned to 5, and you want to perform some operation. Say if x is the same as, let's say if x is the same as 6, you say print number not correct. So you can try another condition. Say elif x is equal to 5. You can say print number is exact, else print not exact. So these are some operations we can try. So when you run this loop, we expect to see it to print the second statement, which is number is what? Exact. Exactly what we get. Yeah. So meaning that x is 5. So we have provided some alternatives for this. So it runs through the first loop and check, is x 6? We said no. You check the other operator, you check if x is 5, yo, x is 5, it prints it. Otherwise, it's not going to print it. Let's say I change my value to 15, and we expect it to print this last statement, meaning that x is not exact. Exactly, not exact. So that is how to use the elif statement. Yeah. So there are logical operators we also need to know. If you remember in our first class, we were introduced to what? Logic. So in Python, let's look at how to program these logic operators. So let's look at how to program these logic operators. I think you still remember the logic rules. Who can remind us the logic rule? The logic table. Anybody? So the logic table says that if you combine true and what? And true, what will be our outcome? Let's make the class interactive. You've done this already. There are things you know. So If you combine true and true together, what do you get? You get true. If you combine true and false, what do you get? You get false. So, and if you combine false and true, what do you get? You get false, right? And if you combine false and false, what do you get? You get false. So this is the logic statement we know in the previous class. And if you are using the OR operator, say if you are using, let's say, true or true. Sorry, I don't have that operator in my statement, in my keyboard, but let me just use OR. Okay, if you are using true or true, what do you get? You get true. In the other way, if you program true or false, you get true. And in the other way, if you program false or false, or false or true, you get true. And lastly, if you program false or false, you get false. Yeah, these are the uh, these are the logic operators that we are used to. Although we can make some advanced computations. So let's look at how we can program this in Python. Of course, you know for the null operator, yes, for the not operator, you can it's either true or false, false or true. Yeah. So you can also combine this in Python environments. So let's say you have a variable called A is assigned to 5, and let's say B is assigned to 10. All right. And you want to program it. You cannot say if A is what? If A is greater than what? 0 and B is greater than. So we are attaching the if conditions to what we are doing. And if B is greater than 0, yeah, we can demand for what? So we can demand for something that will print what? Print both conditions. True. So we can also extend this to like the else statement. Else, what should we expect it to do? Else, print, you can say, oh, print at least. One condition is false. So we can do something like this. So we are using the AND operator. The AND operator says if both the antecedent and the precedent are true, the outcome is true. Yeah. So, and clearly, what we define here, our A and B are greater than 0, and definitely we're going to get the first outcome. So these are logic operators. Yeah, both conditions are true. So if, for instance, I set A to be -5, so clearly A is less than 0, this condition will not be met, meaning that what? It's going to print either of this. The rule says that if the antecedent is false and the precedent is true, then the outcome is false. So definitely it's going to print at least one. Yeah, so at least one condition is false. So that is how the operators work. Do we have any question with how to use the logic operators? Mm, all right. So now let's say we want to assign, we want to use the, okay, let me change this to negative because of readability. Yeah. So let me, yeah, let me use the or condition now. So when I change this to or, so here is the or condition. So we are saying that, okay, the rule says that if the precedence is false, the precedent is false and the antecedent is true, it should return true, meaning that the first statement will be executed in this operation. And let's see how that occurs. Yeah, it's going to return true because at least one is false. So that is what the or operator does. So, and let's say you want to perform the not condition. Yeah, let's say you want to perform the not condition. Say A, let's say A is assigned to 5. So you say if a not operator, now you use the keyword not. If A is less, not, if not A is less than 0, let's use that for instance, then we ask him to print something. Print the value of A is not, say, less than 0. So we can attach the else statement to this. Else, we can say print the value of A is less than 0. So these are, so we want to check the not operator. Code is crying, okay, it's missing. So this is the not operator. Yeah, good. So it's going to print the first one, meaning that A is not less than 0. So we are trying to negate the value. So if you remember your true and false table, so the true and false table says if the antecedent is true, so if the antecedent is true and the negation now, negation of this, negation of A will give me false, right? So let me make it more clear. If A is equals to true, therefore negation of A will be like false, right? So this is what we know. And in similar way, if let's say A is what? Is false, then negation of A will be like what? Will be like true. Yeah, exactly what we are trying to do here. So my A is true. That means A is equals to 5. Then negation will be what? False. So now I'm trying to negate A, and it's saying that A is not less than 0. So yeah, that is very correct. So that is how to use the logic operators in Python. So, and now I can combine more than one logic operators together. So I can combine as many as possible logic operators together. Let me define my A to be like 5. Let me say B to be defined to be 10, and C to be defined to be like, let's say, -3. So we are now saying that, oh, if what? If A is what? Is greater than what? If A is greater than 0, which is clearly true because A is 5 is greater than 0. And okay, we are using the AND operator now. And B is also greater than 0, which is true in this case. Or, so we are adding the OR operator and we want to negate C. So we want to negate C. To negate C now, we're going to use not to negate C. And we're going to like, oh, greater than 0. So now, when you negate C now to be greater than 0, so we can combine these operators logically now. So, and when you do that combination, so you're going to print what? Print conditions are met. Conditions. Okay, let's say condition not met. Else, you say print conditions okay, let's say condition not met because in the first one, I think the conditions are met. So let's run it and see the outcome. Yeah, clearly all the conditions are met because we are combining three things together where we've negate the C. So clearly we are combining these three conditions together. So if you look at the logic operator, you discover that, oh, it's going to return true because of this negation we negate C. So if we did not negate C, for instance, it's going to return the conditions are met also because of this OR operator. Once the antecedent is false, it's going to return false because from this table, you're going to see, so from the OR operator, once the antecedent is false, it's going to return true, rather, yeah. So once the antecedent is false, it's going to return true. So exactly what we've experienced here. Yeah. So negating it also is going to return true because the antecedent is also true. So these are how to use the conditional statement in Python. Although there are some advanced ones. So let's look at, let's say, a real world example. Let me just shift a little bit from a number. Let's say you want to give someone a loan in the bank. So you can incorporate this type of operator into your bank app. If you are developing a bank app, say, oh, if age of a student or of an applicant is 25 years and the income of that applicant, say, is what? 3,000 naira. All right. Can be in naira, can be in dollars. So now we will now set some condition for loan eligibility. You can then say, oh, if age is what? Is greater or equal to what? 18. Clearly, this condition has been met because the applicant is 25. So if age is greater than 18, So you can attach some things to it, and the income of that person, let's say the income is what? Greater than 2,000. The income of that applicant is greater than 2,000. So we'll print this person is what? Is eligible. So we say eligible. Eligible for a loan. So else, it says you should print not eligible for a loan. So this is a clear application of this uh, logic operator. Clearly, this applicant is eligible for the loan, and you can make your program more compatible or more yeah, user generability. So if you want to do that, you can now set let every input be like what? To let every input be like an integer. So, and you can demand, enter your age. Yeah, you can make it more eligible, more user, uh, let it accommodate a lot of user. So enter your age. So the person will enter his age, 56 years old. And when you click on enter, you are eligible for a loan. Excellent. So you can run it for another person. Say, oh, what's your age? And the person just enter 15 years old. Clearly, you are not eligible for a loan. So you can see, so these are some usefulness of this logic operator. So after this class, I will encourage you to dive more deep into this. And so let's say the person is 18 years old. Yeah, not eligible for a loan. Yeah. So these are some practical uh, usefulness of kind of uh, this kind of statements. They are very important, and also they are also relevant for data cleaning. So when you want to clean your data, you can set all of these conditions to clean your data. Any question at this point? If you have questions, you can ask. So in absence of no question, let's look at looping. Let's look at looping. Looping, I think that's the next on the list. Yeah, loop. So there are basically two types of loops. There are more loops, but two relevant loops in Python. The two major relevant loops in Python are the for loops and the while loops. The for loops are loop over an iterable data set or data type. Yeah, and the iterables are basically your list, tuple, strings, range. So these are iterable data types that you can talk about. So why the while loop are mainly used to repeat a condition that is basically true. That means it continue to run whenever that condition is true. Otherwise, it's going to encounter an issue. So these are some basic. So let's look at how to program the loop. So the for loop follows a particular structure. So the for loop follows a particular structure, like you say for, you pick a variable, you say for, and you pick a variable. Let's say for, then followed by a variable. We know what variable means, yeah. Then you're going to use keyword in. This is a keyword in Python, in. So let me asterisk that. So you're going to use a keyword called in. For is a keyword in Python, don't forget. Yeah. Then in, then the sequence. Yeah. So that is the structure of a for loop. Then don't forget to put your colon. It's very important because it's automatically it will create require it for an indentation. So for is a keyword, in is a keyword in Python. So you say for, so let's say a variable. Let's say for variable, let's say x is our variable in a particular sequence. So let's pick a sequence. A sequence we said can be a string. So let's just make it simple. A string, say hello. Yeah. Then you put your sequence, you put your semicolon or your colon. Then what next? You're asking to perform an operator. Print what? Print x. To print that variable. Don't forget, x is our variable. You have to ask him to print your variable. So by so doing, let's see the outcome of this. Let's run it. So running it is going to print all the letters. It's going to loop through all the letters. That is looping. It loops through the first one, it prints H. It goes through the second one, it prints E. Goes through the third, it prints L. Goes through the fourth and the fifth. So that is how to define a for loop in Python. So simple. Now, let's change the variable to variable y. And let's say, oh, I don't want a string anymore. I want it to loop through a list. List is another iterable. So let's say a list of fruits. Okay. Let's say a list of fruits. And let's say our first fruit is apple. The next fruit is what? Is say banana. Let's say the next fruit is um, please, I'm not a fruit person. You can help me with a lot of fruits if you remember. Let's say orange. Yeah. So here is our list. All right. So we want to issue, if you look at this code now, if I should run this code, I'm going to have an error simply because X is not my variable, Y is my variable. So, and let's see if we run that. Yeah, it's going to throw up an error. Okay. But when I change it, yeah, it's going to print out the items there. Yeah, meaning that what is going to print them apple for the first one, banana, cherry, and orange. So that is how to use this. That's how to use for loop to. So you can declare another one. Okay, let's say you want to look over a range. So let's say you want to look over a range. So say for I, your variable, now let's call the variable I, in what? In a range. So range is another iterable. So from range from 1 to 6. So oh, it expects me to put this, yeah. Then print what? Print I. Yeah, when you do this, it's going to print I for us. It's going to print from 1 to 5. Yeah. Please take note. Python is what? Is a zero index based program, right? So what does that mean? It means that it picks the element from the zero index. So this item number 1 is standing in as index 0. Then it's going to print index 0, index 1, index 2, 3, and so on. So that's why it will not print the last value, which is 6. All right. So, and you can also set a range. Let's say you want to print, you can step a set length, you can set a step length into it. Let's say you want to print a range, let's say 1 to, let's say 20, in a step length of what? Of, let's say 2 or 3. Let's say 2. So meaning that he's going to be printing in a step length of 2. After printing the first one, he's going to add 2 to the next one, which is 3. Going to add 2 to the next one, it's going to add so forth. So you can change the step length. So I want to be printing it in a step length of 5. Then it's going to print the first, add 5 to it, which is 6, add 5 to it, which is 11, and so forth. Any question? Yeah. Another wonderful iterable that we also have is a dictionary. So let's define a dictionary of students. Let's say student is our variable. Student is our variable. So, and in an exam, let's say Alice is the name of a student. Sorry, let me set a string. Alice scores, let's say, 60 in an exam. Let's say John scores 50 in an exam. Why are my students not doing well? Let's say Ben, maybe he's the class captain, scores 80 in the exam. The list can go on and on. Let's say for gender balance, let's put Clara there. So let's say Clara scores 78 in the exam. So let's look through this list of students. So you declare your for loop for, let's say, let our variable 1, let's call it name, right? So let's say the name of the student, then the score of the student in where? In student, because our data set now has been defined to be students. So our iterable now is student. So if you run it this way, we're going to get error because if you ask me, oh, print, let's say, print name and score, we may run to an error, just like what we've been doing. Print I, we may run to an error. Yes, it said too many values to pack. So how do we unpack this? So the Python can't unpack something like this. So we need to assist Python to unpack this. To do that, we're going to use another a method called item. So there's a method in Python called items. So all the items that I have in this dictionary, Please unpack it for me. And when you do that, I think we should have, okay, sorry, I'm missing something in my methods. Yeah, it's method. Yeah, so I put the bracket. Then when you run this, yeah, it's going to unpack everything and list them out. So that is how to unpack in Python. A dictionary is a very dictionary is a very sensitive case. Okay, it's a very sensitive one. Yeah. So, but if I want, so remember, in a dictionary, it takes a key and a value, a key and a value, a key and a value. A key, Clara is a key. This is the value. 78 is the value. So I can decide, oh, from this, I don't want to print everything. I want to see only the students in this. So I will just do, oh, from this guy, I need only the key. So print only the key. Oh, good. We have the key only, which is Alice, John, and Clara. Oh, in other words, I may be interested in the what? In the values. So I will say, oh, I need the values only. Then I will specify the values. And when you do that, you get only the values alone. Any question at this point? Please ask questions. And I hope you are coding along. Thumbs up if everything is clear to you. Let me see your thumbs up. Give us a thumbs up if everything is clear to you. All right. Now, there are more to there are more to for loops, okay? There are more to for loops. So let's quickly, because of our time, and this is just a crash course. So let's look at a while loop. Okay, let's look at the for loop with a break. Let's say we want to attach some conditions to the for loop. All right. So we can say, oh, for what? For I in range, let's say 1 to 6, then I will do if I is equals to 3. So to make a conditional, to add condition to a for loop, just use the conditional statement along with it. Then you say, oh, continue. Once it encounter this, continue to what? Continue and what? And print high. So it's going to exclude 3 from the list because it encounters what? It encounters 3, which is the condition we set. If I should say, oh, 5 is our condition, when I run that, it's going to exclude 5 and print all other ones. So we can also use a natural condition, which is another keyword in Python. Let's say the break. Okay. Before we do break, let's do pass. So meaning that if you encounter 5, it should pass. Or let's maybe reduce this to 2. If it encounters 2, what it should do is what? It should pass. So meaning that nothing should happen. And it's going to return everything in the range. And we can also use a break. Say, oh, if you encounter this number 5, what you should do is what? Is break. And it's going to print only 1 to 4. And it's going to break from there. So this is how to use the loop statement. So we can also use them to use the if the for loop to check if a number is greater than another number. Let's say none. So let's say none. The numbers are just a list of 1, 3, let's say 8, let's say 2, let's say 5. This is my list of numbers. I can set, say, max of number. Let me say max value is none. Yeah. Let's say the value in this none, which takes index what? Let's set it to an index of 0. So it's starting from an index of 0. So we can then say forward for none in where? Okay, let's say for x. The variable should not confuse us for x because we are iterating in none. Okay. We will now say if none is greater than max values of index 0. Yeah. Then we can say, oh, or max value is the same thing as none. Okay. We can now print. Let's say print the max value. The maximum value. Maximum value is the max value. Yeah. Let's see what it turns out to be. Oh, yeah. Expect me to put a comma there. It's max value. Okay. It said, oh, greater than or supported for list or hint. Okay. Where do we get this wrong? It's a max number. Okay. Now we say we cannot compare numbers in list together. Anyway, let's proceed. So these are some, let's quickly look at the while loop. So the while loop on its own is used to check why some conditions are true. So we said, oh, why true, why true. So print something. This is a very simple print statement. Why true? We say, oh, print this is and what is an infinite loop. This loop is going to run forever. So because it's always going to be true, it's going to be true. So to avoid that, you're going to put break. Let's see. Yeah, you can see. Continue to print. Going to run like forever till your machine crash. So to avoid this, let me terminate it. Yeah, let me stop it. Yeah. So to avoid this, you can use the break condition. You can use the break condition to help it out. So when you run that, let's see, good. It's going to run only, it's just going to run only once because the first condition is satisfied, but it's going to be running infinitely. So to avoid that, we just what? Break it down. So there are so many practical examples of the while loop. The while loop can also be used for time countdown. So let's say you are having a countdown situation where you want to, so you say, oh, why the countdown? Okay, let's define initialization. Say count. Let's say counter, your count. Your count is a keyword in Python, so let's avoid it. Let's say countdown. So let's say countdown is like 10. So we say why countdown is greater than 0. Print countdown. So we ask him to print countdown, which is just like the countdown. So that we can see the countdown, so we call the variable name itself countdown. So countdown is this. So it's important we do what? We decrement our countdown. Otherwise, we're going to run to the same error we encountered in the first time. So let's decrement our countdown. So decrementing it, you can use our operator, which is like decrement. So decrement countdown by 1. So you say print. If you put the print inside this bracket, you're going to have, okay, it works this way. But I just want us to, okay, let's wait and see. Yeah, it's going to count it down 10, 9. So you can see this is almost similar to the for loops. So it prints it in a reverse direction. Yeah. It's similar to the for loop, but it continues to check the first one. Is it greater than 10? No, it goes next. Is it greater than 10? It goes next. Till it says that, oh, that is at 0 and it's going to stop. Yeah. So that is some relevant importance, some importance of in a similar way, we can make our code. Sorry for the noise in my background. So we look at how to use the control statement, the break, the continue, and the pass. So next on the list is how to use functions in Python. So to use functions in Python, all right, let's look at how to use functions in Python. So functions are just a way to make our code more cleaner and more clear. So, or more simple to use. So functions are very important. It makes our code look so good. So to use function in Python, they are very easy. So these are the basics we need if you want to work on some data. So basically, you need all the things we have been doing, and also this aspect is very important, which is our function. So to define function, so we say use the keyword define. Def is a keyword in Python. So you say define. Let's say our function is salutation, salutes. You want to salute someone. Let's say you want to greet someone in your language. Yeah. And the name of the person is, let's say the name of the person, we provide the name of the person. And these names are called your arguments. They are called what? They are called your parameters, okay? Or yeah, they are called the keywords or the arguments or the parameters of the functions, okay? So now you can, okay, let's say you want to provide only the name of to the person. Yeah. So you can just put a semicolon or a colon by saying print what? Print. How do you want to grade the person? So let me use a formatting techniques called the F formatting techniques. So the F formatting techniques takes a letter F, which stands for format, then followed by what? The way you want to grade, say your hello, then you open a curly braces and say, oh, the parameter you pass the other time, you impute it here, and so this is how to do formatting techniques in Python. So this is not function. This is not function per se, but it's just a formatting techniques. Please take notes. Then you've defined your function. Then you've asked him to perform an operation. And the last step is what? Is to call your function. So the name of our function is what? Salute. So and you call the function by passing in a parameter, an argument. Sorry, a parameter. You pass in a parameter. What's the name of the parameter? Let's say the person's name. So if the person's name is John, so you pass in John. So this is a way of writing. So, and when you run this, it's going to give us, so you're going to say, hello, John. Yeah. So that is a way to define your function in Python. So you have your parameter and you have your arguments. Yeah. So there are many ways of doing that, okay? There are many ways of doing that, but this is just the basic way of doing it. You can define another function using, okay, let's say we want to add two numbers together. So you say define add addition of what? Two numbers. Let's say the numbers are A and B. Then what you've done here is what? This is called function definition. Make sure you always put this column there, is very important. Without the column, your function is not yet defined. So you define your function, then you ask it to perform an operation. So you can use the return keyword. Return. What do you want to do? A plus B. All right. So, and when you do that, the next thing is what? Is to call your function. Okay, is to call your function. When you call your function, you call it with what? With with so with a parameters or with your arguments. Yeah, with your parameters. So what parameters are we putting in? Let's say 4 and 6. So we expect to have 10 as our results. Good. So simple. Any question at this point? So you can also define for subtraction. Say A minus B. So, and when you do this, 4 minus 6, we're going to get minus 2 as our results. So that is how to define functions in Python. So, and you can also define function uh, with keyword arguments, or you can define functions with positional uh, arguments. So you can use keyword arguments or positional arguments to define your. So let's look at how to use it. So this one is just similar to a keyword, a positional argument type. So you can use this one as a positional argument type. So this is just like, oh, salute. So salute. Let's say the name. Let me modify this as salute. Let's say the age of the person. Then, oh, let me modify this a little bit. So saying name, and what else we want from the person. Let's say your age, your age. To put that in a bracket, say age. So you, okay, let's say you are age years old. Yeah. So we can now say, oh, so we can now use a positional argument. So for a positional argument case, say salute John, then you provide a certain argument, which is, let's say the age of John is 25. So this code will not run because of some issues I have there. So yeah, good. I think it's fine this way. Yeah. So this is a positional argument type. Hello John, you are 25 years old. So this is positional argument. You remember how to comment in Python? Yeah. So let's put a comment says positional positional arguments. So let's say positional argument. So this is it. So let's use a keyword argument. So the keyword argument will occur when you are calling your program or your function. So for the keyword case, you're going to have, let's say, keyword. So the keyword argument is like, oh, salute, John. So, but here you're going to specify as a keyword. So the keyword now will just be like, oh, name. Name is equal to, so you are fixing it. Name is equal to this. Age is equals to this. So you can say this is a keyword type. You're going to have the same result, but by the time I change their positions, nothing will happen. I can swap this. Let me call this guy again. So that's the difference between keyword and position. So I can call this guy, or I can change their positions now. Say, oh, John, age is 25, name is John. I can swap their positions and I will still have the same results. I bet you if I do that to this first program, we will have issues. Not issues per se, but logically, the statement will not flow. In fact, for this, we're going to have issues. But let's see. You can see the issue we are having. It's saying that, hello 25, you are John years old. You see what happens there? Because of the positions have been swapped. So you must take note when you are defining your function. Are you using a positional argument type or you are using a keyword argument type? So for keyword, for you are using a keyword, you can reverse their positions. Doesn't affect your program. So these are just some little things we need to. But by default, they use a by default. This is the default for the Python program. So and these are just basics you need to know. So for our arithmetic operators that we've done earlier, so for the arithmetic operators that we've done earlier, so I think we have a function on arithmetic. Yeah. So you can also do that. So let's look at how to use. So you can also do multiplication for this. So, so you can do multiplications, right? And a lot more. So now let's look at how to use libraries in Python. So let's look at how to use libraries in Python. So because as a data scientist, you'll be making use of libraries often. You're going to be making use of libraries often. So there are so many types of libraries in Python, and in this course, you're going to learn how to build your own library as you proceed. Okay. So there are so many libraries in Python. That's why it's the best or is the most sorted after programming language we have because of its enormous libraries. Okay. So Being that said, so let's look at some simple libraries that we have, and we're going to look at how to build your own library. Okay, how to build your own library. So um, let's say to use libraries in Python, you just need to go through the Python documentation and see all libraries that are in existence. Okay, you're going to see all libraries that are in existence. So now for the math operation that we are doing, let me say, okay, you use the keyword import. So the name of the library, so the name of the library is, let's say, math. Okay, so you can import maths, say maths. So with this library at hand, you can now use, oh, print, you can now say, oh, use the library name maths dot what, dot, let's say you want to find the square root of a number, the square root of 16. So you are using the library because this math has what, has has a square root in it, and when you do that, you're going to have 4 as your answer. Okay, so and also you can also decide to, like, oh, I want to do some other operation like pi. I want to compute the area of a cycle. Say, oh, you do maths dot, okay, let's say you define area of a cycle. For area of a cycle, we know that the formula for the area of a cycle, let me use a comment for this. Area of a cycle is like, area of a cycle is like what? Pi, pi what? Times arrow squared, right? So this is what we know, pi arrow squared. So if you want to do that in math, so you define your radius. Let's say a radius is given to you. Radius is like 3 centimeter. So you need pi. You're going to use the math library which you've imported. So you're going to import math library, and you say, oh, import math, then pi. So there is a pi function in maths library. So you're going to do times what? Times your radius squared. So to do square in Python is like, so, and when you print out this, yeah, so this is the area of this cycle. All right, so these are how to use some library. So, but if you have a specific library that you want to, if you have some specific library that you want to, like, what, you want to have uh, some specific functions you want from a library. So you can say, oh, okay, you can say, okay, you can say, oh, from maths, do what? Import. Import what? Let's say you want to import square roots. What else do you want to import? Let's say you want to import pi. What else do you want to import? Let's say sine, right? Or let's say, um, what else can we import? Okay, let's just import these two for instance. So these are what you import. So you can also use them. So to make our class faster, so you can just do okay. The radius is, let's say, 5 centimeter. Then you want to compute the perimeter now. So perimeter is like, so perimeter is like 2 pi r, right? 2 pi r. Yeah. So which is like, you just do, so your radius, so this become 2 times pi times r. Yeah. So and when you do that, so we have, so we're going to do math pi times r times 2. Yeah. So, oh, from math, import, okay, it's like our, we don't need to do, we just need to use pi directly. Sorry for that. So you don't need to use pi directly because that's what we've imported. So we just say 2 pi r because we've imported it already. Yeah. Why is my code crying? From math, import pi. Okay, yeah, yeah, that's fine. So we import pi from this and we can use it to compute the area, the perimeter of what? So we can set it to a variable called perimeter. So for storage ability, then what you need to do is to print your perimeter. Yeah, good. So these are how to use some of the libraries. So another, I think in the last class we looked at how to use the random library. So now you can form your own library, okay? You can form your own library. So let me quickly walk us through how to formulate your own library. So, but let me quickly use the VLC environment, okay? Permit me to use a VLC environment, okay? So let me open this folder I created last time called internship. Yeah, let me open VLC from here. Let me open this file with VLC. Yeah. All right. So now to create your own environment, your own code, you create your own library or your own. Okay, folder is not open. Yeah. So to create your own library, you create modules. Okay, they are called modules. Okay, so let's say you have a module. Let me start from scratch. So you create a Python a Python script. Let's call it module. Module.py. You create your module. So let me go and import those functions that we've created earlier. So let's say you've defined a function for what? For addition. Let me copy this and put them here. So I have for multiplication, or let me change this to addition. So let me populate this. So I have defined another one for what? Subtraction. Let me populate this. I've done for what? For division. or for multiplication, and let me populate this for what? For division. So we have four functions here. So let me quickly change the names. This is subtraction, division. This is multiplication. This is subtraction. And this is addition. So we have four different functions here, right? So define four functions here. So now we create another file, save it as what? We call that file, let's say the file is class 2, but it's a Jupyter notebook. Save it as IPYNB. So now after we've created this, so we can now say, oh, the name of our module now is what? So we say the name of our module is what? Is module. So we now say, oh, import what? Module. So just do import module. So import module. And what do you want to do? You say, oh, from my module dot what? Dot addition. Then what do you want to add? Let's say you want to add 15 and 70. And when you run this, we expect to have what? 85. Good. Our module is working. That's how to create your own function. I can come to the next cell. I create, oh, I want subtraction. So I want to import subtraction from my module. I will do like, oh, subtract 15 from 70. I think that should be about 65 or 55. 55 negative. Yeah, our module is working. Also, you can import your module with an alias. Instead of saying, oh, import my module, you can say, oh, import module as what? As, let's say, MD. So, but instead of saying module dot add, you can just say md dot add. So it's a shortcut. Programmers are lazy. They want something easy. So say import it as md and you still have the same result. I can do divides. So that is how to create your own module. So that is how to create your own module. So I want to do division. So we said md divides, let's say 70 divides 10. We expect to have 7 as our result. Excellent. So remember, we talked about the integer modulus last week. So we can also create another function to it, say integer modulo, integer divisor, integer, let's say integer division is our module. So and this takes double what? Takes something like this. And you can also create modulus as your operator. And with this, you can form your calculator. So modulus, which we use what? Percentage, right? If you remember all of this, good. So you go back to this. I want to perform an operation. You can say, oh, I don't want to import the whole library because it contains so many functions. I want a specific function from that module that we created. You can just say, oh, from module import. What are we importing? We are importing modulus. So we have we have a function called mode, right? If you check very well, we have mode there. So which we just like division reminder. So it will returns reminder. So you now say, oh, mode dot what? Mode of what? Mode of mode of 3 and 4. We expect to have 1. Okay, let me say module. Then we import module from this import module. It's a module of 3 and 4. Said cannot import name type module from module. Okay, we'll figure out that later. So we can say we'll import, let's say, division. So we want to find the division of what? 3 and 4. Yeah, that's how to import a specific module your from your module, a specific function for your module. So let me use this again. Let me just like import what? Import add. So add 3 and 4, and we get 7. Good. So this is how to import a specific what? A specific value or a specific function from your module. So we've seen how to create our own module. So I think after this class, you will become an expert in module creation. So let me return us back to the sheets and look at some other libraries that are very important. So among the libraries that are also very important is your pandas library. So let's look at how the pandas library works. So pandas, so you can read more about pandas. It's one of the largest library you can think about. So pandas is used to read a lot of data. Okay, basically CSV data, Excel data, type, or a lot of different files. So it can be used for files. So let's look at how we can create a simple file from the data library. So if you want to use a pandas library, so um, you can use the word import. So it's used to create table. Yeah, let's just use that word. Used to create table. So and you can say import pandas. You can do import pandas. So for simplicity, you can say import it as what? As PD. All right. So now let's input some data. You remember we have a dictionary. Let's say our dictionary, because of time, I don't know if I can create those dictionary again. So let's say our data contain a list. A dictionary contain a list. So let's say a list which is names of people, right? So let's say the names are Alice is my friend. Can use our good friend Alice. And the age of Alice is like 24, or let's say 23. Let's say Alice lives in New York, or let's say Alice lives in New York. maybe in an exam, he scores, let's say, 88 in the exam. All right, so let me populate this. So let's say John is another good guy. And let's say John is 33 years old and he lives in, let's say, Canada, and he scores 68 in an exam. And let's say we have Ola. Let's say Ola is, let's say Ola is 20 years and he lives in, let's say he lives in Lagos, and he scores 90 in an exam. So let me add one more to this, one more list. Let's say we have Jude, another brilliant guy. He's 25. He lives in, where does, he lives in Chicago. And he scores 60 in an exam. All right. So this is our dictionaries of what? Dictionaries of lists. So if we should check the type of data set, let's look at the type of data that we have. If you print the type, you're going to see that, okay, I've not run this. Yeah. Oh, what happened to my data? Okay. Oh, sorry. Let me create it as a list instead of dictionary. Let me make it easier. Let me create a list. Yeah. Yeah, let me create a list. So this is a list of list. Yeah. So this is a list of list, okay? So a list that contains several lists. So now we can define, we can convert this to a table. So we can say, oh, define columns to it. Let's add some columns. So let's say the columns are just like lists. So they are the names. It will take name, it will take age, and it will also take city. Um, it takes city, and it also take what? Scores. Yeah, take the scores of the students. So that's the column. So we want to convert this list now into what? Into a data type. With the help of pandas, we should be able to do that. So we said our data frame will be like what? PD dot what? So use the key, there's a keyword which is data type, data frame. All right, we want to convert it to a data frame. So, and what are we passing to the data frame? The data we have. Let me create this in a new line. So let me run this. So we have the data frame, sorry, PT. Yeah, we passing the data to it, and we want the columns to be assigned to what? To columns, because we create a column already. Yeah. So when you run this now, let's say you print data frame, you're going to get this. Yeah, we have a good data frame now. Correct. So which gives us a good outlook compared to this list that we have here, right? So I hope you are still with me. I hope you are following. All right. So we'll be rounding up in the next 5 minutes. So with this now, let's check the type of what of DF now, because we've transformed it to another type. So if we check the type of DF now, you'll see that, oh, it's now a data frame. It's no longer a list. So when you do that, so you can see that, oh, it said DF is now a pandas data frame with a structure, things like this. So it gives us the data types that we have. Or you can say, oh, D type. I think there's a way to check it more better. D type. D type, something like that. Yeah, D type of DF. I don't know. Okay. So now you can start manipulations of this table. You can say, oh, you can say, okay. You can do, okay, I think I recall df.d type. Df.d type is going to give you the data type you have here. Yeah. So it's giving us the data type as what? As an object. The name is seen as an object. Age is seen as an integer. Yeah. It's going to give us the data types we have in all of this. Okay. So it says the data type of our data type is what? Is an object. And that is what Python basically does. All right. So you can also look at so many things about this table. You can say, okay, df.info. You can do df.info. Yeah, it describes your data type for you. All right. So you have your data types. Say you have 4 entries. Then your name is a non-null. There is no missing data there. All right. You can do df dot. You say I want to see only the first 2 items. Df dot head of my data, which is just only the first 2 items because our data are not lengthy. So it gives us only the first 2 items of your data frame, which is what? Alice and John. And if you go back and see, the first 2 data here are Alice and John. All right. So you can start your manipulation from here. So, okay, I want to describe this table. Let me see, describe, df.describe to summarize the table. All right. So this is how this library is so important. So it summarizes the table, saying that, oh, the ages that we have there, we have 4 scores, 4 ages. Yeah. The mean age is 25 and the mean score is what? Is 76. The standard deviation, STD represents standard deviation. The standard deviation is 5 and the standard deviation of the score is this. And the minimum age is 20 and the maximum minimum score is what? Is 16. The 25% of the age is 22 and then so it gives us some statistics. So and these are called data storage system. So, so that is some little things about that. So from here now we cannot pick it up. We cannot start moving to data exploration and data analysis. So this is just for what? This is just for a a list. So you can also do that for a dictionary. So if time permits, or just give me 2 minutes if I can do that for dictionary. So and dictionary, they are very important. So we've done that of list. So you can do that of dictionary if time does not permit us. But let me just spend the next 1 minute and create that of dictionary. So for dictionary, it follows the same, but let me just copy the data to make things easier. So let me copy all of this into a new cell. So let's say you're having a dictionary. So for a dictionary, change this guy to dictionary. So we change it to dictionary. We change it to dictionary type. So instead of Alice to be inside of the bracket, Alice should stand on its own, and we should have our square should contain a list of something. So here it should be like semicolon. Yeah. So yeah, for the dictionary type, John should be here. Then we should have something like this. Yeah, Alice is still crying. All right. So for John here, so this should take a key and a value. For Jude, should be the key, and this guy should be the value. So this is how you define your data. Yeah, we have Alice is the key, John, Ola, and Jude. So you can specify the column if you wish. If you don't wish, yeah, okay. Or let's make it more simpler. So let's have its name. It's a name. Name is this. Then we should have Alice to be included. So Alice should be included. So basically, I just need to redefine everything because yeah. So let me pick name. I put it in column. Let me say age, city, and scores. Yeah, let's do it this way. So the name. So the names are, we have Alice, the names are John, and Ola, and Jude. So these are the names. The age, the ages are like, the ages are like, let's say 20, 25, 26, 30. Let's say these are the ages. And the city, let's define the city to be like Lagos, Canada, Lagos, Canada, let's say Ghana, for the glass guy, let's say Togo. All right, and for the scores, we can have, let's say 60, 65, 70, 78. So these are the scores. So all we just need to do is to okay df dot what dot pd, because we've imported our pandas as pd, then dot data frame, then our data. Good. So let's call our df now. We have an error saying that what data frame, oh sorry, it's not pf but pd. Yeah, good. Okay, df is equals to this. So here we have our table also, name, age, city, and score. So we are using a dictionary approach to define our data frame instead of what? Instead of a list that we did earlier. So this is where we end our class for today. I'm open to questioning. Any question? Any questions so far? All right. In absence of no question, we'll meet again next week, Wednesday. Thank you.